Tonight, we're going somewhere no human has ever been. Not to another country, not to another planet, but far beyond everything you've ever known. Before this journey begins, I want you to do one simple thing. Leave everything behind. Leave today's worries. Leave tomorrow's responsibilities. Leave the stress, the noise, the endless thoughts that have been following you all day. For the next few minutes, none of them matter, because tonight we're about to look at the universe from a perspective so vast that every problem on Earth becomes almost impossible to see. Together, we'll travel back to the very beginning of time. We'll witness the birth of the universe itself. We'll stand before black holes so powerful that even light cannot escape them. We'll ask questions that science still cannot answer. Do white holes really exist? What happens after crossing the event horizon? Could time actually slow down or even stop? Are we truly alone in this unimaginably vast universe? Or is someone somewhere looking up at their own night sky, wondering exactly the same thing? We'll visit worlds where glass falls from the sky like rain, stars so massive they make our sun look insignificant, objects so dense that a single teaspoon of their material would outweigh a mountain. And by the end of this journey, you may never look at the night sky the same way again. So sit back, relax, and let the universe tell its story. Subscribe segment. If you're fascinated by the mysteries of space and the questions that continue to challenge science, consider subscribing to the channel and turning on notifications. We have many more journeys ahead, and each one explores another corner of this incredible universe. And before we begin, leave a comment below with one question you've always wanted answered about space. Who knows? It might become the next journey we take together. Now, let's begin. About 13.8 billion years ago, there was no Earth, no sun, no stars, no galaxies, no black holes, not even a single atom of the oxygen you breathe, or the iron flowing through your blood. There was nothing that resembled the universe we know today. And then something happened, something so extraordinary that even after more than a century of modern physics, scientists are still trying to understand exactly how it began. We call it the Big Bang. But don't let the name fool you. It wasn't an explosion that happened somewhere in space, because there was no space. There was no empty universe waiting for something to explode inside it. Instead, space itself was being born. Time itself had just begun. Imagine drawing two tiny dots on a balloon. Now begin inflating it. The dots move farther apart, not because they're traveling across the balloon, but because the balloon itself is expanding. That's one of the simplest ways to imagine what happened to our universe. Except this wasn't a balloon, it was reality itself. And for a tiny fraction of a second, the universe expanded at a rate so unimaginably fast that some regions moved away from one another faster than the speed of light. At first, that sounds impossible. Isn't light supposed to be the fastest thing in existence? Yes, nothing can move through space faster than light. But space itself isn't bound by that rule. Space can stretch, it can grow. And in those first moments, it expanded with unimaginable violence. Then, something remarkable happened. The universe began to cool. Not in minutes, not in days, but over hundreds of thousands of years. As the temperature dropped, the first simple atoms finally appeared. Hydrogen, helium, the basic ingredients from which nearly everything else in the cosmos would eventually be built. But the universe was still completely dark. No stars illuminated the sky, because there was no sky. only endless clouds of invisible gas drifting through an expanding ocean of space. Then gravity quietly took over. Across millions of years, those enormous clouds slowly collapsed under their own weight. The pressure increased, the temperature rose, until, for the very first time, the darkness lit up. The first stars were born. These weren't gentle stars like our sun. They were cosmic giants. Some were dozens, even hundreds of times more massive than the sun. They burned hotter, brighter, and far more violently. Their lives were incredibly short, but their deaths changed the universe forever. When these ancient giants reached the end of their lives, they exploded in unimaginably powerful supernovae. For a few moments, one dying star could outshine an entire galaxy. And inside those colossal explosions, nature created something extraordinary: carbon, oxygen, silicon, iron, gold, uranium. Almost every heavy element in existence was forged inside stars that died billions of years before Earth even existed. The calcium in your bones, the iron in your blood, the oxygen filling your lungs. Every atom was once inside the heart of a star. Astronomers often say something that sounds poetic, yet is scientifically true. We are made of stardust. Those first stars didn't remain alone for long. Gravity gathered billions of them together, then hundreds of billions, slowly. The first galaxies began to appear, great rivers of stars spinning through the darkness, each one carrying countless solar systems, countless worlds, and perhaps countless stories waiting to be discovered. One of those galaxies would eventually become our home. A spiral galaxy stretching nearly 100,000 light years across, containing somewhere between 100 and 400 billion stars. A galaxy we know today as the Milky Way. The Milky Way. It may look peaceful when you see it stretching across a clear night sky, a faint river of light, quiet, beautiful, almost fragile, but appearances can be deceiving. Hidden deep within its glowing heart lurks something so powerful that it controls the motion of millions of stars, something that cannot be seen, cannot be touched, and emits no light at all. Its name is Sagittarius, a star, the supermassive black hole at the center of our galaxy. It lies about 26,000 light years from Earth, and although it occupies a region smaller than our solar system, its mass is equivalent to around 4 million suns. Think about that for a moment. Imagine compressing 4 million stars like our sun into a single object. The result is gravity so intense that not even light can escape. This is why black holes appear completely dark, not because they're empty, but because they imprison light itself. Surprisingly, if our sun were magically replaced by a black hole with exactly the same mass, the Earth wouldn't suddenly be pulled in. Our planet would continue orbiting exactly as it does today. The only difference would be eternal darkness. The danger of a black hole isn't magical, it's gravity. Pure, relentless gravity. And yet, even Sagittarius A star is far from being the biggest monster in the universe. In fact, compared to what astronomers have discovered elsewhere, it's almost modest. Far beyond the Milky Way, more than 10 billion light-years from Earth, lies one of the largest black holes ever found. Its name is TON 618. Its estimated mass is around 66 billion times the mass of our Sun. 66 billion suns. It's a number so enormous that the human brain struggles to visualize it. If Sagittarius A star is a giant, TON 618 is a titan. Its gravitational influence stretches across a region larger than many entire solar systems, and despite its unimaginable size, it is almost certainly not the largest black hole that has ever existed. The universe has a habit of reminding us that every record we break may simply reveal an even greater one waiting beyond. But here's something even stranger. Black holes don't wander through space looking for things to swallow. They're not cosmic vacuum cleaners. Movies often show them pulling in entire galaxies without mercy. Reality is very different if you stayed far enough away. A black hole behaves just like any other object with the same mass. Its gravity follows the same laws. Its presence is invisible until you get too close, and once you cross a boundary known as the event horizon, there is no turning back, no engine, no technology, not even light itself can escape. But that raises one of the greatest mysteries in modern science. If nothing escapes, then where does everything go? Does it simply disappear forever? Is it crushed out of existence? Or could black holes be hiding a doorway into somewhere else for decades? Physicists have searched for an answer, and that search has led to ideas so extraordinary that they blur the line between science and imagination. But before we explore those mysteries, we need to understand another kind of cosmic giant, objects so unbelievably dense that a single teaspoon of their material would weigh about 1 billion tons on Earth. They are called neutron stars. When a massive star reaches the end of its life, it doesn't always become a black hole. Sometimes, something even stranger is left behind. Imagine a star several times more massive than our Sun. For millions of years, it shines brilliantly, producing unimaginable amounts of energy. Then, its nuclear fuel runs out. Gravity suddenly wins the battle. In less than a second, the star collapses. Its outer layers explode across space in one of the most violent events in the universe, a supernova. What's left behind is a neutron star. At first glance, the name doesn't sound particularly impressive, but the reality is almost beyond belief. A typical neutron star is only about 20 kilometers, 12 miles, across, small enough that you could drive around it in less than an hour, yet inside that tiny sphere is more mass than our entire sun. The matter is compressed so tightly that the atoms themselves are crushed apart. Electrons and protons merge together, forming an ocean of neutrons unlike anything found naturally on Earth. The result is one of the densest objects in the universe. A single teaspoon of neutron star material would weigh around 1 billion tons. That's roughly the weight of a mountain, balanced on the tip of a spoon. If you somehow managed to drop that spoon onto Earth, it wouldn't simply fall to the ground, it would punch straight through the planet. Fortunately, such a thing can never happen. But neutron stars have another extraordinary ability. Some spin hundreds of times every second. Imagine an object heavier than the sun, rotating faster than the blades of a kitchen blender. As they spin, they emit powerful beams of radiation into space. If one of those beams sweeps across Earth, we detect it as a perfectly regular pulse. Tick, 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 like the heartbeat of the universe. These remarkable objects are known as pulsars. Some are so incredibly precise that they rival the accuracy of the finest atomic clocks ever built. And yet, even these incredible stars are dwarfed by something far larger, our own sun, to us. The sun feels unimaginably enormous. It contains 99.8% of all the mass in our solar system. More than 1 million Earths could fit inside it. Every second, it converts about 600 million tons of hydrogen into helium. a process that releases enough energy to power our entire civilization for billions upon billions of years. Without it, life on Earth would vanish almost instantly. But in the grand scale of the cosmos, the sun is simply average. Now imagine a star called Rigel, one of the brightest stars in our night sky. It shines tens of thousands of times more brightly than the sun. Its surface burns at temperatures far hotter than anything our star can produce. And beyond Rigel, astronomers have discovered true giants. One of them is called Stephenson 2-18, one of the largest stars ever identified. If this colossal star replaced our sun, Mercury would disappear, Venus would disappear, Earth would disappear, Mars, Jupiter, even Saturn would all lie inside the star itself. Light, the fastest thing in the universe, would need hours just to travel from one side of this star to the other. Trying to compare Stephenson 2-18 to our sun is like comparing a single grain of sand to a mountain. And yet, the universe still isn't finished surprising us, because stars are only half the story. Around many of them orbit worlds that seem impossible, worlds where molten rock glows beneath black skies, worlds where an entire planet may be covered by a single endless ocean, worlds where winds scream at thousands of kilometers per hour, and where rain doesn't fall as water, but as razor-sharp glass. One of those worlds is called HD 1897333b, and its story is unlike anything on Earth. There are places in the universe that seem impossible, worlds so strange that if an astronomer had described them just 100 years ago, they would have been dismissed as pure fantasy. And yet, today, we know they exist. Let's begin with a planet unlike anything in our solar system, a world called HD 1897333b. At first glance, it looks beautiful. From space, it appears as a deep sapphire blue sphere, almost peaceful, almost inviting. If you didn't know better, you might think it was another Earth, but that beautiful blue color is one of the greatest illusions in the cosmos, because beneath those clouds, hell is raging. The atmosphere reaches temperatures of nearly 1,000 degrees Celsius. Winds scream across the planet at more than 8,000 kilometers per hour, nearly 7 times faster than the speed of sound. And then it begins to rain, not water, not snow, but tiny shards of molten glass, driven sideways by those incredible winds. The glass doesn't fall toward the ground. It flies horizontally, like billions of microscopic razor blades. If a spacecraft somehow entered that atmosphere, it wouldn't survive for long. The planet is beautiful only from a distance. Up close, it becomes one of the most violent places ever discovered. But even that isn't the strangest world we found. Travel nearly 40 light years from Earth, and you'll reach another extraordinary planet. Its name is 55 Cancri E. This world circles its star so closely that one entire year there lasts only about 18 Earth hours. Imagine celebrating New Year's Day every single day. Its surface is hot enough to melt iron. Rivers of lava may flow across entire continents. The ground itself glows red beneath an eternal sky. Some researchers have even suggested that enormous pressures inside the planet may have created vast quantities of diamond deep below its surface. Imagine a planet where mountains of crystal could exist, yet no human could ever touch them, because everything would melt long before reaching the ground. And still, the universe keeps raising the stakes. There is a planet called TRES-2b. It reflects less than 1% of the light that reaches it. It is darker than charcoal, darker than fresh asphalt, almost darker than black paint. If you floated nearby, you might barely see it at all, only a faint crimson glow produced by its extreme heat. It is one of the darkest worlds humanity has ever discovered, a planet hiding in plain sight. Then there's WASP 12b, a giant world orbiting so close to its star. That gravity is literally pulling it apart. Astronomers believe the star is slowly consuming the planet. Its atmosphere stretches into space, like water spiraling down a drain. Every second, the planet loses a little more of itself. One day, it may disappear completely, not because it exploded, but because its own star ate it alive. And as incredible as these worlds are, they're only a tiny fraction of what's out there. Some planets may be covered entirely by oceans hundreds of kilometers deep. Others may have no solid surface at all. Some orbit two stars, where two sunsets paint the sky every evening. Others drift through the darkness alone, without orbiting any star, frozen, silent, invisible, entire worlds, wandering endlessly through interstellar space. The more we search, the stranger the universe becomes. And perhaps the most astonishing discovery isn't that these places exist. It's that we've only explored an unimaginably small corner of the cosmos, which raises an unsettling question. If nature can create worlds like these, what else is hiding out there, waiting to be found? Imagine this. Your spacecraft is drifting silently through the darkness ahead of you. There are no stars, no light, just a perfectly black circle suspended in space. The black hole. You've crossed the point where turning back is no longer possible. The engines are still running, nothing seems broken, everything inside the spacecraft feels normal. But outside, reality has already begun to change. From the perspective of someone watching you from Earth, something extraordinary happens. As you approach the event horizon, your movements begin to slow. Not because your spacecraft is losing speed, but because time itself is slowing down. Your voice becomes lower, your motions become slower. The light coming from your ship grows redder and dimmer. Then you appear to freeze forever. To the outside universe, you never actually seem to cross the event horizon. Your final image remains suspended at the edge of the black hole, growing fainter until it disappears into darkness. But from your point of view, nothing unusual happens. You don't freeze, you don't stop. You simply continue falling. You cross the event horizon without seeing a wall, without hearing an alarm, without even realizing the moment you've crossed it. And that's one of the strangest facts in modern physics. The event horizon isn't a physical surface, it's a boundary in space-time, a line from which nothing, not even light, can ever return. Now imagine the black hole is relatively small. As you fall deeper, gravity begins pulling on your feet much harder than on your head. At first, the difference is tiny, barely noticeable, but every second it grows stronger. Your body begins to stretch, your bones, your organs, even your atoms are pulled apart by the enormous difference in gravity. Physicists call this process spaghettification. It's an oddly humorous name for one of the most violent deaths the universe can offer. You wouldn't simply be crushed, you would be stretched into a stream of matter thinner than a strand of hair, every molecule separated, every atom torn apart, until nothing remains of the person you once were. But here's something most people don't know. That terrifying fate depends on the size of the black hole. If you were falling into a supermassive black hole, like Sagittarius A star at the center of our galaxy, You might pass through the event horizon without immediately feeling anything unusual. The black hole is so enormous that the difference in gravity between your head and your feet at the horizon is surprisingly small. Your journey inward could continue for minutes or even longer before gravity finally becomes overwhelming, and then you reach the greatest mystery of all, the center, the place physicists call the singularity. According to Einstein's equations, matter is compressed into a state of seemingly infinite density, infinite gravity, infinite curvature of space-time. But here's the truth. We don't actually know what happens there. Our equations stop working. General relativity predicts one thing, quantum physics predicts another, and the two refuse to agree. It's as if the universe itself is telling us, you've reached the edge of your understanding. Then another mystery appears. Suppose a black hole eventually evaporates, because according to Stephen Hawking, black holes slowly lose energy through something now known as Hawking radiation. Over unimaginable lengths of time, even the largest black holes may eventually disappear. But if they vanish, what happens to everything they swallowed? Every star, every planet, every atom, every piece of information? Does it simply cease to exist? That can't be right, because one of the deepest principles of quantum physics says information can never truly be destroyed. This puzzle has challenged the greatest physicists on Earth for decades. Some believe the information escapes, others believe it is somehow preserved on the event horizon itself, and others argue we still don't understand black holes well enough to answer the question, but one idea, more extraordinary than all the others, suggests that perhaps a black hole isn't the end of the journey at all. Perhaps it's only one side of another door. What if a black hole isn't the end? What if everything that disappears into one eventually emerges somewhere else? That idea may sound like science fiction, but surprisingly, it didn't begin in Hollywood. It began inside Einstein's equations. When physicists explored the mathematics of general relativity, they discovered something unexpected. The same equations that predict black holes also allow another, far stranger possibility. An object that behaves in exactly the opposite way. A place where nothing can enter, but everything can come out. They called it a white hole. If a black hole is the universe's ultimate entrance, a white hole would be its impossible exit. Imagine standing in front of one. You wouldn't see matter falling inward. You would see matter, light, and energy being violently expelled into space. No spacecraft could fly inside. No particle could cross its boundary. Everything would be pushed away. It would be like standing in front of a cosmic waterfall, flowing in reverse, an endless stream, with no visible source. It sounds extraordinary, and that's because it is. There's just one problem. No one has ever found one. Not a single telescope, not a single space observatory, not a single scientific mission has ever detected a confirmed white hole. Today, white holes remain purely theoretical, a fascinating consequence of mathematics, not an observed object. But that hasn't stopped physicists from asking an even bigger question. What if every black hole is connected to a white hole somewhere else? Imagine dropping a book into a black hole. Instead of being destroyed, could it emerge millions of light years away from a white hole? Some researchers have explored exactly that possibility. Others have suggested something even more astonishing. What if the Big Bang itself was the birth of a gigantic white hole? What if our entire universe began as matter and energy erupting from one? It's an incredible idea, But it's important to be honest. There is no evidence proving this is true. It's one of many fascinating hypotheses, not an established scientific fact, and perhaps it never will be. But if black holes could somehow connect to white holes, how would that connection work? This question led physicists toward one of the most famous ideas in modern science, the wormhole. Imagine taking a sheet of paper. You draw one dot in the top corner, another in the bottom corner. Normally, you'd have to travel all the way across the page, but now, fold the paper. Suddenly, the two dots touch. Instead of crossing the entire distance, you simply pass through a shortcut. That's the basic idea behind a wormhole, not a tunnel carved through rock, but a shortcut through space-time itself. If one existed, it could connect opposite sides of our galaxy, or perhaps two entirely different galaxies. Some theories even suggest it might connect different universes. It's one of the most exciting concepts ever proposed. But once again, reality is less forgiving than imagination. According to our best calculations, a wormhole would almost certainly collapse almost instantly, before even a single particle could pass through it, unless something held it open, something with properties unlike any matter we've ever discovered. Physicists call this hypothetical substance exotic matter. Matter with negative energy density, a form of matter that, as far as we know today, has never been observed. So once again, the universe gives us another beautiful possibility, and then quietly whispers, "Not so fast." The deeper we explore, the stranger reality becomes. Ideas that once sounded impossible appear naturally inside the equations of physics, yet proving them is an entirely different challenge. And that brings us to another mystery, one that doesn't require black holes or wormholes, because it may already be happening to all of us, every single second. The mystery of time itself. If I asked you, what is time? You might answer without hesitation, seconds, minutes, hours, days, something that moves in only one direction. Forward, never backward, never stopping. But according to modern physics, time is far stranger than our everyday experience suggests. It isn't simply a clock ticking on a wall. It isn't an invisible river flowing through the universe. Time can stretch. It can slow down. And under the right conditions, it can pass at different rates for different people. This isn't science fiction, it's one of the most thoroughly tested predictions of Einstein's theory of relativity. Imagine two identical twins. One remains on Earth, the other boards a spacecraft capable of traveling at 99.99% the speed of light. Years pass. When the astronaut finally returns, something impossible seems to have happened. The twin on Earth has grown old. The traveler has aged only a fraction as much. Neither person's clock was broken. Neither experienced anything unusual. Each one lived normally, inside their own flow of time. Yet, they no longer share the same age. This phenomenon is called time dilation. And unlike many ideas in physics, we know it's real. In fact, it happens every single day. GPS satellites orbiting Earth experience time slightly differently than clocks on the ground. If scientists ignored that tiny difference, your phone's GPS would drift by kilometers in just a single day. Every route, every map, every navigation system would slowly become inaccurate. Einstein predicted this long before satellites even existed. Reality eventually proved him right. So, can we travel into the future? In a way, yes. Every astronaut aboard the International Space Station travels a tiny fraction of a second further into the future than the rest of us. The effect is incredibly small, but it's real. Travel fast enough, or remain near an extremely powerful gravitational field, and time slows down for you, meaning that when you return, the rest of the universe has moved further into the future. But now comes the question everyone asks. What about traveling backward? Could you visit ancient Egypt? Could you witness the dinosaurs? Could you stop history from unfolding the way it did? Here, physics becomes much less certain. Imagine traveling back in time and preventing your grandparents from ever meeting. If they never met, your parents would never exist, which means you would never be born. But if you were never born, who traveled back to change the past? This is known as the grandfather paradox, one of the most famous puzzles in theoretical physics. Some scientists believe paradoxes like this mean that traveling into the past is simply impossible. Others suggest history may be self-correcting, no matter what you try. The past somehow refuses to change. And then there is an even stranger possibility. Perhaps every decision creates another branch of reality, another universe, another timeline. In that case, traveling into the past wouldn't change your history. It would create or enter a different one. This idea is closely related to the concept of the multiverse, a collection of countless universes, each with its own version of reality. Perhaps somewhere there is another Earth, another sun, another version of you, making different choices, living a different life. It's a breathtaking idea. But once again, there is no experimental evidence confirming that such universes exist. For now, they remain possibilities born from mathematics and theory, not established facts. The deeper we explore time, the more mysterious it becomes. It refuses to behave the way common sense tells us it should. And perhaps that's because common sense was shaped by life on Earth, not by the universe itself. But after all these mysteries, one question still remains. If the universe is so unimaginably vast, if planets are everywhere, if the ingredients for life exist across the cosmos, then why have we never found anyone else? For thousands of years, human beings have looked toward the stars and wondered one simple question. Are we alone? Is Earth the only place where life has appeared, or somewhere among the countless worlds scattered across the universe? Is another civilization looking back at the sky, asking the same question? The numbers alone are difficult to comprehend. The observable universe may contain around 2 trillion galaxies. Each galaxy may contain hundreds of billions of stars, and around many of those stars there are planets, worlds with oceans, worlds with atmospheres, worlds with the basic ingredients that life requires. When we look at these numbers, a strange thought appears. Maybe Earth is not special because it is the only place where life exists. Maybe Earth is special because it is one of many places where life has awakened. But then a mystery appears. If the universe is so large, if there are so many opportunities for life, where is everyone? This question became famous as the Fermi paradox, named after physicist Enrico Fermi. The idea is simple. The universe is billions of years old. Even a civilization only slightly more advanced than ours could potentially spread across an entire galaxy over millions of years. So, if intelligent civilizations are possible, why don't we see any evidence of them? Why don't we detect their signals? Why don't we find their technology? Why does the universe appear so silent? Scientists have suggested many possible answers. Perhaps intelligent life is extremely rare. Maybe creating a civilization capable of reaching the stars is almost impossible. Maybe the conditions that allowed humans to exist are far more unusual than we realize. Another possibility is that civilizations do exist, but they are simply too far away. The universe is enormous. A signal traveling at the speed of light still needs thousands, millions, or even billions of years to cross the distance between stars. A civilization could send a message today, and another world might not receive it until long after that civilization has disappeared. The universe may not be silent, it may simply be too large. There is also another possibility. Maybe advanced civilizations do not communicate the way we expect. For more than a century, humans have searched the sky using radio waves. We listen for unusual signals, patterns that could not easily occur naturally. This effort is known as SETI, the search for extraterrestrial intelligence. So far, no confirmed alien signal has been discovered, but that does not mean nothing is there. It only means we haven't found it yet. And then there is perhaps the most unsettling possibility of all. What if civilizations are common, but they rarely survive long enough to explore the galaxy? Every civilization faces challenges, resource shortages, environmental changes, conflicts, technological dangers. Maybe reaching the stars is not the hardest step. Maybe surviving long enough to reach them is. But let's imagine for a moment that somewhere out there, a civilization does exist. Not thousands of years ahead of us, not millions, just a little more advanced. What would they think of Earth? Would they see us as intelligent explorers? Or would we appear to them like a young species, still learning how to control its own world? Would they try to contact us? Would they avoid us? Would they even notice us? Because from a cosmic perspective, Earth is incredibly small, a tiny planet orbiting an ordinary star, located in one ordinary region of one ordinary galaxy. Yet somehow, this small world produced something extraordinary, a species capable of looking across billions of light years and asking questions about the universe itself. Perhaps the greatest discovery we could ever make would not be finding another civilization. Perhaps it would be discovering that consciousness itself is one of the rarest things in existence. But before we finish this journey through the unknown, there is a mystery even larger than alien life. Because when scientists study the universe and they discover something shocking, everything we can see, every star, every planet, every galaxy, every black hole, everything we know may represent only a tiny fraction of reality. The universe is hiding something, something invisible, something everywhere around us, and to understand it, we must enter one of the greatest mysteries in modern science, the mystery of dark matter and dark energy. Look at the night sky, the stars above you, the glowing galaxies captured by powerful telescopes, the planets moving silently through space. Everything you can see, everything humanity has ever touched, everything we have ever discovered, makes up only a tiny part of the universe, a very tiny part. For a long time, scientists believed that if we could simply build better telescopes, if we could observe deeper, farther, and with greater precision, we would eventually see the entire universe. But the universe had a surprise waiting. The more we looked, the more we realized. Most of reality is hidden from us. Imagine standing in a huge forest at night. You hold a small flashlight. The beam reveals a few trees around you. You can study their shapes, their colors, their details. But beyond the light, there is an enormous forest that you cannot see. That is how humanity currently views the cosmos. We see the glowing parts. But most of the universe remains invisible. Scientists discovered this mystery while studying galaxies. According to everything we understood about gravity, the outer stars of galaxies should be moving much more slowly. The weaker gravity at the edges should allow many stars to escape. But they didn't. They remained connected. They moved as if something invisible was holding the galaxy together. Something with mass, something creating gravity, but something that does not produce light. Scientists gave this mysterious substance a name: dark matter. Not because it is black, not because it absorbs light like a shadow, but because it does not interact with light in the way normal matter does. We cannot see it, we cannot touch it, we cannot collect it, yet its gravitational influence appears everywhere. It is like seeing footprints in the snow, without ever seeing the person who made them. Dark matter may surround galaxies like an enormous invisible web, a cosmic structure that helped shape the universe itself. Without it, the galaxies we see today may never have formed. But just as scientists began accepting that the universe contained invisible matter, they discovered another mystery, something even stranger. The universe is expanding. We already knew this. For decades, astronomers observed that distant galaxies were moving away from each other, but then they discovered something unexpected. The expansion of the universe is not slowing down, it is speeding up. Something is pushing galaxies apart, something that seems to fight against gravity itself. Scientists call this unknown force dark energy. And here is where the mystery becomes almost impossible to imagine. Dark matter helps hold things together. Dark energy appears to push everything apart. Two invisible forces, working in opposite directions, shaping the destiny of the entire universe. But what exactly are they? No one knows. We have ideas, we have theories, we have mathematical models, but we still do not understand the true nature of the majority of existence. The universe we see may be only the surface of something far deeper, and perhaps the most humbling discovery of all is not that the universe is enormous. We already knew that. It is that even after thousands of years of observation, after building machines capable of seeing billions of years into the past, after sending humans beyond Earth, we are still standing at the beginning of understanding. There are questions we cannot answer yet. What existed before the beginning of time? What happens beyond the edge of the observable universe? Are there other universes beyond our own? Will the universe expand forever? Or will it one day transform into something completely different? Maybe somewhere, far beyond our current vision, there are answers waiting, answers hidden among the stars. But perhaps the greatest lesson of this journey is not about the universe, it is about our place inside it. Every worry, every fear, every problem that feels enormous in our daily lives exists on a tiny planet, orbiting an ordinary star, inside one galaxy among trillions. From the perspective of the cosmos, we are incredibly small, almost invisible. Yet somehow, that tiny planet created beings capable of understanding the universe, atoms created inside ancient stars, gathered together, forming oceans, mountains, life, and eventually, conscious minds that can look back toward the stars and ask, why are we here? Maybe the universe is not just a place we live in. Maybe it is a story we are part of, a story that began billions of years ago with the birth of the first stars and continues now with every person who looks into the darkness and wonders what is waiting beyond. This journey has only shown us a small part of what exists. The universe is still full of mysteries, and perhaps that is what makes it so beautiful, because every answer creates another question, and every discovery opens another door. The cosmos is not a finished story, it is an endless journey, and we are the ones lucky enough to witness it. And now, after traveling across billions of years, after witnessing the birth of stars, the death of worlds, the darkness of black holes, and the mysteries hidden beyond what our eyes can see, we return to where this journey began, Earth, a small blue planet, floating silently in an ocean of darkness. From the perspective of the universe, Earth is almost nothing, a tiny world around an ordinary star, inside one galaxy among trillions. The mountains we climb, the borders we create, the problems that sometimes feel impossible, all of them exist on a small island of life drifting through an enormous cosmos. But perhaps that is not a reason to feel insignificant. Perhaps it is the opposite, because in all this vastness, somehow, the universe created something capable of looking back at itself. Atoms created inside ancient stars came together. They formed planets, they formed oceans, they formed life. And eventually, they formed minds that could ask, why are we here? The same universe that created galaxies millions of light years wide created a human being capable of imagining them. The same universe that hides mysteries inside black holes created curiosity powerful enough to search for answers. Maybe we are small compared to the cosmos, but our ability to understand it is something extraordinary. There are still questions waiting. What exists beyond the edge of the observable universe? Are we truly alone? Will we ever understand what lies inside a black hole? Are there secrets hidden in the darkness that we have not even imagined yet? Perhaps humanity will spend centuries searching for these answers, and maybe that is the greatest part of the journey, because the universe is not a story that has already ended. It is a story still being written. Every star we discover, every planet we explore, every question we ask adds another page. So, the next time you look at the night sky, remember, those stars are not just points of light. They are ancient worlds, ancient stories, reminders that you are part of something far greater than yourself. You are made from the remains of stars that lived and died billions of years ago. You are the universe, trying to understand itself. And until we discover all its secrets, there will always be another mystery waiting beyond the darkness, another question, another journey, and another reason to keep looking at the stars.